Welcome to the unbelievable story of the atom. Everything around you, your phone, your food, your body, your chair, even the air you breathe, is made of atoms. But scientists didn't discover atoms in one day. So today, we are traveling through time to understand the complete history of the atom in the easiest and funniest way possible. Let's begin our atomic journey. Back in 1803, a scientist named John Dalton gave the first proper atomic theory. Dalton looked at matter and said, everything is made of tiny particles called atoms. Now according to Dalton, atoms were like tiny solid balls. No holes, no charges, no particles inside, just hard little spheres. Basically, Dalton imagined atoms like tiny cricket balls floating everywhere. His model became famous as the solid sphere model. Dalton also said that atoms cannot be divided or destroyed. He believed atoms of one element are different from atoms of another element. For example, hydrogen atoms are different from oxygen atoms. And when atoms combine together, they form compounds. Like hydrogen plus oxygen becomes water. Honestly, for that time, Dalton's theory was revolutionary. Scientists were impressed. Everyone was like, wow, this guy cooked. But science has one rule. No theory survives forever. A few years later, another scientist entered the scene and completely changed the story. His name was J.J. Thomson. In 1897, Thomson performed a famous experiment using something called a cathode ray tube. Now imagine a glass tube with electricity passing through it. During the experiment, Thomson noticed mysterious rays moving inside the tube. And these rays were attracted toward the positive side. That meant these particles were negatively charged. Boom! Dalton's solid atom theory started breaking apart. Thomson had just discovered the electron. The atom was not indivisible anymore. There was something inside it. Thomson called these tiny negative particles corpuscles, but today we call them electrons. Now Thomson needed a new atomic model. And this is where things became deliciously weird. He imagined the atom like a plum pudding. If you don't know plum pudding, just imagine a chocolate cake with chocolate chips inside it. The positive charge was spread everywhere like the cake, and electrons were embedded inside it like chocolate chips. This became famous as Thomson's plum pudding model. Scientists accepted it for some time. But then came a scientist who absolutely destroyed this model using gold foil and alpha particles. His name was Ernest Rutherford. In 1909, Rutherford and his students performed one of the most legendary experiments in science history. They fired positively charged alpha particles toward a very thin sheet of gold foil. Now according to Thomson's model, these particles should easily pass through the atom because the positive charge was spread out evenly. So Rutherford expected all particles to move straight. Simple, easy. But science said, plot twist. When the literally said it was almost as surprising as a cannonball at tissue paper and having it bounce back. So what did Rutherford conclude? He said the atom must contain a tiny, dense, positively charged center called the nucleus. This nucleus contained most of the atom's mass, and the electrons moved around this nucleus. Thus, Rutherford gave the nuclear model of the atom in 1911. According to this model, atoms have a small dense nucleus. The nucleus is positively charged. Electrons move around it and most of the atom is empty space. Suddenly, atoms looked less like pudding, and more like a mini solar system. But Rutherford's model still had problems. Scientists were confused about how electrons stayed in orbit without crashing into the nucleus. Then in 1913, Niels Bohr improved Rutherford's model. Bohr said electrons do not move randomly. Instead, they move in fixed paths called shells or energy levels. Think of it like floors in a building. Electrons can stay only on specific floors. They cannot exist between floors. And if an electron gains energy, it jumps to a higher shell. If it loses energy, it falls back down. Basically, electrons were now doing parkour inside atoms. This became the Rutherford-Bohr model. Scientists loved this idea because it explained many observations about atoms. But wait, another mystery appeared. Scientists knew the nucleus had positive charges called protons. But something didn't add up. Hydrogen had 1 proton and a mass of 1. Makes sense. But helium had only 2 protons. Yet its mass was 4. Where was the extra mass coming from? Was the atom secretly eating protein powder? In 1920, Rutherford predicted that another particle must exist inside the nucleus. A particle with no charge. He called it the neutron. But nobody could find it for years. Until finally, in 1932, James Chadwick solved the mystery. Chadwick fired alpha particles at beryllium and detected a strange neutral radiation. This radiation could knock protons out of paraffin wax. After many experiments, Chadwick proved that the radiation consisted of neutral particles with mass similar to protons. The neutron had finally been discovered. And now, scientists understood the 3 fundamental subatomic particles. Protons, positive charge. Neutrons, no charge. Electrons, negative charge. Protons and neutrons stay together inside the nucleus. Electrons move around the nucleus in shells. And this became the foundation of the modern atomic model. According to the modern model, the atom has a tiny dense nucleus containing protons and neutrons. Electrons exist around the nucleus in specific energy levels. Most of the atom is empty space. And the number of protons determines the element. For example, carbon has 6 protons, so its atomic number is 6. Oxygen has 8 protons. Hydrogen has 1 proton. Simple. But here's the most important lesson from this story. Science changes with evidence. Scientific models are not permanent. Whenever new experiments give unexpected results, scientists improve old models or create new ones. That does not mean previous scientists were stupid. It means science is working exactly how it should. Dalton gave the base. Thomson discovered electrons. Rutherford discovered the nucleus. Bohr explained electron shells. Chadwick discovered neutrons. Each scientist added one piece to the atomic puzzle. And together, they built our modern understanding of the atom. So next time you hear the word atom, remember, inside that tiny particle is more than 100 years of scientific adventure. If this video helped you understand the history of the atom in an easy and fun way, then make sure to like the video, subscribe to the channel, and share it with your friends.